Maximal classifiers, you're saying, nope, it can only be one line and that line has to fit the data perfectly. Support vector classifier, maybe we can make some mistakes. We can allow some mistakes if the plane is a little better. And then support vector machine says, well, who says it has to be a plane? It could be anything we want it to be, right? So that's basically kind of what we're going to look at, right? It's kind of like a graduated scale of what you're going to allow. Now, obviously, you're introducing a few more errors along the way, right? That's why the maximal margin exists, because that is like the no error approach. But, you know, in some cases you're saying, I'm okay with some errors if it gives me if it's still a reasonable model, right? So that's kind of like what I want you to think about. Like I said, if you remember anything, remember this, because these are the different types of classifiers that are out there. Okay? Wasim says neural networks are hard to interpret though. Not always. One, they're not always hard to interpret, and two, you don't always need interpretation, right? Not every problem requires interpretation. Depends on the problem. And there are some techniques to make neural networks interpretable. So I don't agree with that blanket statement, right? As scientists, we should always be careful about making blanket statements. So I don't agree with your blanket statement. There's ways around it. Okay. Sahara, I hope I'm pronouncing that right. I think it's Sahara. Sahara says, what are real life projects where you would typically use SVMs?